Hello students, welcome you all to the PT Chap, and for this video lecture we'll discuss about the topic SC and OC lines. We know SC for short circuit and OC for open circuited line. Look at that, how the voltage and currents they are distributed on a lossless and a lossy line like this for a open circuit. The open circuit, we know the second end is open. Okay, then look at that, the dotted line gives you the dotted line, what I mentioned, that this gives you the distribution of voltage, and this one gives you, the dotted line gives you the current, right? Okay, so these are distributed. There is no change in that magnitude, value remains same. But whenever we are considering the lossy line, now look at that, the wave value has been reduced to that when we go for a distance. Okay, there may be some consideration where we have the maximum amplitude, that one is called as a nodes, where we have that minimum values, that is called as an antinodes. Okay, so these 2 points you need to be calculated for a open circuited, and also for the short circuit, remember. Okay, so this is quite opposite what I mentioned. Here in the open circuited, the current starts at 0, the voltage starts at some value. Okay, but here for the short circuit, the voltage starts at 0 and they are start at some value. The current starts at some value on this, right? Okay, so once you get these values, okay, for a lossless line, and there is a lossy line for that, the short circuit too. Okay, so in this particular diagrams I will explain that the distribution of voltage and currents along a transmission line for a lossy as well as the lossless lines. Coming to that, the diagrams on the screen, the first diagram is for a open circuit. For the open circuit, remember, this is the voltage source and this is the current source IS, and this is the second end is open. What is this called? The impedance which is measured at input terminals of a transmission line is called the open circuit. Okay, ZOC. ZOC means open circuit impedance, right? And coming to the second diagram, we have, this is for the short circuit. For the short circuit, the second end is closed. What is the main difference? The second end is open for the open circuit line. The second end is closed for that the short circuit line. Yeah, this is ZSC. ZSC, which mean the impedance which is measured at the input terminals of a transmission line. Here, look at that. ZSC means impedance of a finite line transmission line whose second end is closed, right? Whose second end is closed. And ZOC means impedance of that finite line transmission line whose second end is open. Okay, these two are that very important for your particular topic, ZSC and ZOC. Can I go for the transmission line basic expressions? We studied under that the transmission line equations. V is equal to Vs into cos h gamma z minus Ia z naught into sin h gamma z. This is the what expression as well. Current is equal to minus 1 by z naught into Vs into sin h gamma z minus Ia z naught into cos h gamma z. So many times we are giving the same expressions. Remember, that is the why the transmission line equation is one of the best question for examination point of view. Keep on remember these two expressions. On many derivations also we have to remember the transmission line equations. Okay, so for at the source end, let me go for what is the source end conditions. Source end, it becomes Z is equal to 0, V becomes Vs, source voltage, I becomes Is, source current, right? Then at the load end, how this expression becomes? Because it is a Z is equal to 0 and this end is called Z is equal to L, some length. What is that length? Finite length, what I mean. Okay, Z is equal to L, V becomes VR and I becomes IR. These are the conditions of a line with that input, the source end and the load end. So I need to find the load end. How this expression becomes at the load end? V becomes VR. Look at that expression. V becomes VR there. VR is equal to Vs into cos h gamma L, because Z becomes L, h gamma L minus Ia Z naught into this Z becomes also L. Okay, then I becomes IR of minus 1 by Z naught into Vs sin h gamma L minus Ia Z naught into cos h gamma L, right? For OC line, let me go for the conditions again. What are the conditions? For a OC line, the current is minimum, right? Okay, so IR is equal to 0 and VR is equal to maximum. The conditions are very, very important for a OC line where voltage maximum where current is 0. For a SC line, the current is maximum, voltage is 0. Okay, when you keep on these points, there is no problem on the derivations too. IR is equal to 0, VR equal to max. So take that IR value. So I take that minus 1 by Z naught Vs sin h gamma L minus Is Z naught cos h gamma L is equal to 0, or Vs cos h gamma L Z naught tends to 0, Vs sin h gamma L is equal to Is Z naught into cos h gamma L. That means Vs by Is is equal to, exactly this is open circuited impedance, ZOC is equal to Z naught, term is there, cos by sin becomes, it is the cot L. Finally I got ZOC is equal to Z naught into cot h gamma L. Already this expression is known to you earlier, but here in the topic wise we have discussed about the same part. Okay, then coming to the SC line, the short circuited line, can I know the conditions? Anyone? What are the conditions? Where IR is equal to max, then VR is equal to 0. Can I go for that VR equal to 0? Take that VR expression. VR expression, it is Vs cos h gamma L minus Is Z naught into sin h gamma L is equal to 0. That implies Vs cos h gamma L is equal to Is Z naught into sin h gamma L. Then ZSE is nothing but Vs by Is, substitute that values, Z naught into sin h gamma L by cos h gamma L. That implies ZSE is equal to Z naught into tan h gamma L. Very important expression, this one also. Okay, yeah, this is the most important bit for online. So many times it was given for the mocks also, for 3 mocks short answers of this problem only, or same formula only. What happens when I multiply the equation 1 and the equation 2, where ZSC and ZOC, 1 into 2. Yeah, remember ZSC into ZOC is nothing but, we have Z naught term is there, Z naught square, and cot h gamma L into tan h gamma L. Multiply the things, okay, then ZSC into ZOC is equal to Z naught square, or I find very important relation, Z naught is equal to root of ZSC into ZOC. Definitely 3 marks are there for this important formula. Why? Because in that problem ZSC is given to you, ZOC given to you, he is asking about Z naught. If you remember this formula, hope you will get 2 or 3 marks, no doubt about it. Okay, Z naught is equal to root of ZSC into ZOC. What happens if I divide the value equation 2 with that equation 1? Okay, so equation 2 is ZSC by ZOC is equal to Z naught tan h gamma L by Z naught cot h gamma L. Z naught get cancelled, then tan h gamma L by cot h gamma L, I can write it as 1 by tan h gamma L. So it comes to the numerator tan h square gamma L, right? Tan h square gamma L is there, but what is that? Square root of this one gives you tan h gamma L, and finally tan h gamma L is equal to root of ZSC by ZOC. And can you tell me, the based on this expression, what is the line? What is the length of that? Nothing but 1 by gamma tan h inverse of root of ZSC by ZOC. Maybe this one is also important for doing the problems on this particular topic itself, right? Okay, so this is all about that. What is the transmission line, SC and OC lines, and what are the different cases to study of this the particular topic. Thank you.